everybody. First of all, I would like to thank Ottmar and Skip for the invitation. It's a pleasure to be here. So the talk I'm going to give, or the paper I'm going to present, is in many ways similar to the work that Rob has just presented. The main motivation is also to investigate the rationale for carbon tax as part of a broader fiscal reform package aimed at reducing public debt. And so a carbon tax can obviously reduce greenhouse gas emissions, but it can also raise revenue that could be used to repay some of the debt and thereby relax future interest obligations and create future surpluses in budgets, which could then, for example, be recycled through lowering distortionary taxes. So that's very similar to what we've just seen presented by Rob. So this paper, so the question here of this paper is, can we make a carbon tax more attractive or even socially desirable if we combine a carbon pricing policy with a debt reduction policy? And obviously, so why could it be beneficial? So we could use a carbon tax to repay public debt, lower interest payments on the debt, and thereby create future budget surpluses that we could then recycle in the future. And obviously, there's an intergenerational issue here, so an intergenerational equity issue here, so current young generations or, current old generations or young generations that will not live long enough to reap the benefits of future relaxed budgets are going to bear the burden, whereas future generations may gain. So it's obviously important then here to understand the efficiency and distributional effects of using carbon tax revenue to reduce public debt. We're going to look at alternative ways of using the revenue from the carbon tax and to either lower taxes or repay the public debt. And we're also going to look at the intergenerational and intragenerational distribution implications. And we also want to take some a social welfare assessment of whether overall there could be overall efficiency gains from combining a carbon pricing policy and a public debt reduction policy. And then also the question is, of course, if the concern is about public debt reduction, one should also contrast the efficiency impacts of raising revenue to consolidate public debt by comparing a carbon tax with other potential revenue raisers. Okay, and as Rob has just pointed out, the literature so far on the interaction of environmental taxes with the broader tax system has either looked at static models or they have employed infinitely-lived agent models where the Ricardian equivalence holds. So in order to get around that Ricardian equivalence, the contribution of this paper is to use an overlapping generation models and to consider using the carbon revenue to repay the principal debt. And we're going to use then a numerical model that's calibrated to the US, which is basically an Auerbach-Kotlikoff OLG model. And we combine a standard Auerbach-Kotlikoff model with a typical large-scale energy economy CGE model that's typically used to investigate climate and energy policy issues. So let me briefly give you one slide overview of the model. So as I said, it's a numerical dynamic general equilibrium model with overlapping generations, similar to the Auerbach and Kotlikoff model. We also include, besides intergenerational heterogeneity, we include 5 different household types within each generation that represent quintiles of lifetime wage income that are calibrated based on data from Altic et al. the model is a multi-sectoral model which has 15 different sectors. It models primary energy production, electricity, energy-intensive industries, other manufacturing, transportation services, and so on, and thereby includes the standard CGE setup with multiple sectors and the input-output structure and intermediate goods. The model is based on the GTAP8 database, and in order to solve the model, because we have many sectors and also different household types within each generation, we're using a decomposition algorithm that solves the equilibrium of the OLG economy by a sequence of infinitely lived agent economies. Okay, so the key mechanism here is that we use the carbon revenue today to repay the principal debt, and thereby we create surpluses in the future in the government budget that can be recycled by using, for example, by lowering distortionary taxes. And this is the last equation you see here on this slide, which is the public deficit, and we hold G government spending and T transfers fixed, and then N would be varied depending on the specific debt repayment schedule, and then phi here is tax revenue, which comprises tax revenue from all non-CO2 taxes in the model, as well as the carbon tax revenue, and so we capture also then the erosion of the tax base if you impose a carbon tax through this term phi here. Okay, so the scenario I want to focus on here is a very simple thought experiment. So let's assume there's a carbon tax of $20 per ton CO2 initially, and increasing at 4% per year for the next 50 years. And assume we have 3 revenue recycling instruments, capital, labor, and consumption taxes. And then I'm going to look at 2 kinds of scenarios. So one are the conventional carbon tax swap scenarios that have been already looked at in the literature, although not with exception of the paper by Rob in an OLG context. So here we leave the public debt unchanged, and then a second set of scenarios are the debt scenarios where the carbon revenue is used to repay principal debt, and then the future budget surpluses from reduced interest payments finance tax rate cuts in either one of these 3 instruments. Okay. So let's first look at the swap scenarios, and here are the welfare impacts by generation measured in Higgs equivalent variation, and generations are identified by the year they are born in the model. So you have for each generation you have the welfare impact from the policy, and households or generations live here for 50 years, and the carbon tax, recall, is implemented for 50 years, starting in year 0 of the model. And so what you first see here is that mostly the generations lose from a revenue-neutral carbon tax swap, except for the old generations under a consumption tax recycling scenario, which is because they have relatively high shares of consumption. They also have relatively high shares of capital income, which is why they are hurt only relatively little. Whereas when you recycle the carbon revenue through lower taxes on labor, the current old generation lose. And then as you move to the right of this axis, the carbon tax becomes more stringent. Therefore, you have, for all of these 3 cases, these hump-shaped profiles of impacts. What you see, however, is that the patterns of intergenerational welfare impacts are very different and depend on the specific recycling instrument. You see here that with labor tax recycling, most of the burden falls on elderly and young generations, while capital recycling tax puts most of the burden on future generations. So now, if we move to the debt repayment case, And this is similar, I think, to the third set of scenarios that Rob has just shown you. You see here that by taking the carbon revenue today and repaying debt and then recycling the future budget surpluses through lower taxes in one of these instruments, you impose larger burdens for elderly and subsequent young generations, while the future generations gain. And this is simply due to the effect of, or this is the pattern that's borne out by the debt consolidation scenario. And let us look at how a carbon tax compares with other revenue raisers. So here, this graph is a bit busy, but you have 3 pairs of scenarios, where each pair of scenarios compares a case where the same debt repayment schedule is implemented using, for example, a capital tax rather than a CO2 tax. And you see for all of these cases here that taking a capital labor or a consumption tax instead of a carbon tax produces smaller losses for the generations. So the dashed lines here, which represent the debt repayment cases, are always below the solid lines, which represent the debt repayment with one of the other capital taxes. Okay, and of course, this is so. If you're only concerned about debt consolidation, and if you ignore the environmental benefits, then these other revenue raisers are superior compared to a carbon tax. We can also look at the intragenerational impacts here, and I'm just showing one example here, which compares the impacts from a lump sum recycling of the revenue under debt repayment case versus a labor tax recycling, and the households within one generation are heterogeneous with respect to their earnings ability, and we assume identical preferences, so the spending side of households or the preferences are similar. But you see here that even with this core specification of household heterogeneity, that these two cases produce very different intragenerational impacts across the generations within one generation. With the lump sum transfer case benefiting the poorest quintiles and entailing losses for the rich households, whereas the labor tax recycling benefits a household with a high earnings ability. Okay, and now if we come back to this debt repayment cases, and if we take a very direct social welfare function approach to aggregating the intergenerational impacts, and I've plotted here a case for rho equals to 1, which is basically then the utilitarian social welfare function, where the social welfare is just the weighted sum of the impacts of generations, where theta is reflecting population and discounting. Then you see here that under the swap cases, where you take the revenue from a carbon tax and lower taxes today, that for this for the broad range of social discount factors, there's a negative welfare effects for the social welfare index. Whereas if you take the debt consolidation cases or the debt repayment cases, for sufficiently low social discount rates, there's an overall positive societal assessment of this. Okay, so I conclude here. So overall, the costs and the distribution of that cost vary widely based on how the carbon tax revenues are used. And we saw that the carbon tax swaps imply welfare losses for all generations. However, if you combine a carbon pricing policy with a fiscal consolidation policy, then current old and young generations are worse off, but future generations gain. There is substantial intergenerational variation in the impacts, and we also saw that if the policy objective is just about consolidating public debt, then other non-CO2 tax instruments are more efficient to raise revenue. Okay, thank you.
Thanks very much.